In this video, we're going to review the basics of scientific notation. So scientific notation is used because quite often in science and chemistry, we're going to be dealing with numbers that are very, very, very large or very small. So we use scientific notation, number one, to make the numbers more manageable, but also so we can accurately express how many significant digits a measurement or a value has. So in this chart that I have from the book, this is basically it's kind of like the metric system, except they don't have the labels on here. So the metric system is what we'll use to like annotate measurements. So grams can become milligrams or kilograms, and meters, we could have centimeters or millimeters. So the centi, the milli, the kilo, all that part of these measurements that I keep on mentioning, that's part of the metric system. And in here, we've got the most common ones that you'll see. So for example, 10 to the 6th, that one's mega. 10 to the 3rd is a very common one. That one corresponds to kilo, as in a kilogram. There is 1,000 grams in 1 kilogram. 10 squared, not too common, but that one's hecto. 10 to the 1st power, also not too common with just our everyday chemistry stuff, but that one's deca. The 10 to the 0 is known as the base unit, so we don't have a special name for that one. 10 to the minus 1, that one is deci. Not too common, but then the next few are very common. 10 to the negative 2 is centi, as in centimeter. 10 to the negative 3 is milli, as in milliliter or millimeter. And then 10 to the negative 6, that one's micro. Micro won't necessarily be too common in fundamental chemistry, but it does come up quite often in higher levels of chemistry. So now I'm going to do a whole bunch of examples on how scientific notation works, and specifically converting back and forth between traditional numbers and scientific notation. And we will review sig figs along the way as we do this, because one purpose of scientific notation is to preserve how many significant figures, or at least make it perfectly clear how many significant figures are in a value. So 75,000, that has 2 sig figs. Now the decimal point for this number is located right here. We don't have any zeros after it, so that's why we don't usually write the decimal point, but it's still there. Now to convert to scientific notation, we want to convert such that we have exactly 1 digit, and then the decimal, and then as many after the decimal as is necessary so that our value has or is expressing the correct number of sig figs. Then we'll have the multiplier times 10 to some exponent, so that corresponds to what we saw in the table. So we essentially need to move this decimal point. We need to move this decimal point over to here so we have the 1 digit plus whatever else is necessary on the right side. The multiplier, so this lowercase n, is basically how many times did we move that decimal. So if I'm going to move this decimal, I'm going to count. It goes 1, 2, 3, 4 places to the left. So our multiplier is going to be a 4, and specifically a positive 4 because we're moving it to the left. So our answer is going to be 7.5, and then we're going to have a times 10 to the 4, and I'll explain in a minute why it's 4 and not negative 4. And then in terms of sig figs, so our original value had 2 sig figs, so it's just going to be 7.5 times 10 to the 4, because 7.5 has 2 sig figs, and our original quantity had 2 sig figs before we put that orange decimal point in there. Now, it's 10 to the positive 4 because we're taking a larger number and we're making it smaller. So if you go up here, you'll see that the positive exponents, so those corresponded to very, very large numbers. 75,000 was a large number. Positive exponents correspond to large numbers that are greater than 1. And then negative exponents correspond to quantities that were smaller than 1. So let's look at, we have a few that are larger than 1, and then we have a few examples down here that are smaller than 1. So we're just going to go through each one, and hopefully it'll start to make sense as you see the pattern. So this one, 478000000, very, very large number. There is a decimal right here that wasn't put in. In terms of sig figs, the 4, the 7, and the 8 are significant. All the other zeros were considered placeholder zeros. So this has only 3 sig figs. We're going to want to move the decimal to the left. So 1, 2, 3, 4, 5, 6, 7 places to the left. So it's going to be a 10 to the 7th. And then now we rewrite it where the decimal is in this spot. So 4.78. 4.78 times 10 to the 7th. And 4.78 also has 3 sig figs, just like the original quantity. Next example. So we have a 1, we have an 8. Those are significant. These zeros in the middle are being sandwiched. So this is a 4 sig fig quantity. All of the other zeros are just placeholder zeros. And then here is our decimal point that was not written in before, but it's there. And we want to move it over to where the 1 is. 1, 2, 3, 4, 5, 6, 7, 8, 9 times we moved it. So times 10 to the 9th. And then since these 4 digits were all significant, we need to make sure we include all 4 of them. So we're going to have 1.008. Now this new quantity that we wrote, I mean, it's the same quantity, but it's just a new way of expressing it, but it also has 4 sig figs. And that's how it should be. Next one, 100.56. So our decimal is already here. That's good, but we need to move it all the way over. We're only going to move it 2 times. So it's going to move 1 2 times. So times 10 to the 2. And now all of these digits were significant. So the 1, the 5, and the 6, and these zeros as well because they were sandwiched. So this quantity had 5 sig figs. We need to make sure over here we also have 5 sig figs. So 1.0056. So this has 5 sig figs. Next one, an 8 with a whole bunch of zeros after it. Here's our decimal. We want to move it over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to have times 10 to the 12th. Now, none of those zeros were significant. All of these zeros here they were all placeholder zeros. We only had 1 significant digit. So this is just 8 times 10 to the 12th. 1 sig fig over here. You'll notice with all of these, the times 10 to the part of it doesn't count for your significant figures. It's just the part in front of that multiply, in front of that x, that counts for sig figs. So now we're going to do a few examples where we're going the other way. So we're starting in scientific notation and we're converting it into a regular number. So all of these were these 3 examples here, these are all, they've got a positive exponent, which means we're going to make the number bigger. So 1.56 is going to turn into some large number, like 1 million something or something. But let's work through it and see what we have to do. So here's our decimal. We need to move it this direction, and it needs to move 8 times because we have an 8 right here. So 1, 5, 6, I've moved it twice, and then I'm going to have to add 6 zeros. 1, 2, 3, 4, 5, 6. So here's the new location of our decimal. It was right here. Moving it this direction, we moved it 8 times to get there. So 1, 2, 3, 4, 5, 6, 7, 8, just to kind of verify. And then in terms of sig figs, this 1.56 had 3 sig figs. And then this 156 also has 3 sig figs. All of these are placeholder zeros. I'm not going to write in the decimal. I just put it there just to help me figure out where am I moving the decimal from. I moved it from between the 1 and the 5, and I moved it over to here just as a way to count up how many zeros do I need to add. But it's actually, that decimal is not there in our final answer. We're not going to write it in. Next one, we have 1.47 times 10 to the 4th. So the 4 here means we're going to move this decimal this direction 4 places. So 1, 4, 7, and I'll need to tack on 2 more zeros in order to move the decimal from this spot over to this spot. Now in terms of sig figs, 1.47 had 3 sig figs, and 14700 without a decimal actually written in also has 3 sig figs. These are your significant figures. The zeros that are on the right, those are just placeholder zeros, they don't count. Next one, 4.700 times 10 to the 10th. We're going to take our decimal right here and move it to the right 10 times. So 4700, that's 3 places moved. Now I have to add 7 more zeros. 1, 2, 3, 4, 5, 6, 7. So let's check that we did it correctly. The decimal was right here. We moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Now in terms of sig figs, 4.700 had 4 sig figs. Now we're not going to actually write the decimal over here, because if we wrote in this decimal right here, we'd be saying we have 11 significant figures, and that's not true. I just erased a 0. So one thing that we can do, and I mentioned this in a previous video, is we can put a line over the last significant 0 to communicate to others looking at our work that, hey, this 0 is significant. The 4 and the 7 are, and then this 0 with the line over it is also significant, which means this one is now a sandwich 0, so it is also significant. So we have 4 sig figs. All of these other zeros are placeholder zeros. They do not count. But it's that line over the top that we'll use to try and communicate that this value should have 4 sig figs, even though we wrote it as a regular number. So now a few examples going the other way. So now we're starting with very small numbers, numbers that are less than 1. So going back to the table, recall, we're now going to have exponents that are they're all negative, basically. So -1, -2, etc. Negative exponents in scientific notation tell you have a very small number. These are all regular numbers. We're going to convert them into scientific. Here's our decimal. And we have to move it right here between the 5 and the 6 so that we have that format of 1 digit, a decimal, and then however many digits are necessary times 10 to the exponent. And it'll be negative in this case with all these numbers that are smaller than 1. So our decimal, we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 times. So that means we're going to have a 10 to the -8. And then these were our significant digits. All of these others were placeholder zeros, so they don't count. But the 5, the 6, and the 3 do. So this is a 3 sig fig quantity. So our answer should also accurately reflect that it's 3 sig figs. So we'll write 5.63. Next example, here's our decimal. We want to move it over here between the 9 and the 1. And then observing our sig figs, all of these are significant. So the 9, 1, 4, 7, 8, of course, are all significant. This 0 is also significant because it's after the decimal, after non-zero digits. So this has 6 sig figs. Sorry, I'm on eraser. 6 sig figs. So we just need to make sure when we write the scientific notation form, it also has 6 sig figs. So now in terms of moving our decimal, we're going to move this decimal 1, 2, 3, 4, 5 times. So times 10 to the -5th. Next, we're going to fill in all those digits we had before. 9.14780. So now this part of the number has 6 significant digits, because again, that 0 counts. And then times 10 to the negative fifth reflects the fact that we moved the decimal to the right 5 times. Next example, 0.00320. So here's our decimal. We need to move it right here. We're going to have to go 1, 2, 3 hops to the right. So that's 10 to the negative 3. And then once the decimal is in the spot, we're going to have a 3.20. So 3.20 times 10 to the negative 3. The 0.00320 had 3 sig figs, and 3.20 has 3 sig figs, so we're good. Next example. Here's our decimal. We need to move it all the way over here, again, because it's 1 digit, a decimal point, and then whatever else is necessary to have the correct number of sig figs. So that means 1, 2, 3, 4, 5, 6, 7, 8 times, so times 10 to the negative 8. And then the digit here, it's just an 8. So this number by itself just has 1 sig fig, which is just the 8. So our scientific notation way of writing it should also have 1 sig fig. Last example. Here's our decimal. We want to move it here because that's after the first non-zero digit. So 1, 2, 3, 4, 5 times. So times 10 to the negative fifth. And then we want to copy down all of this with the decimal now in this spot. So 4.00780. So the first way of writing the digit, the number, we had 1, 2, 3, 4, 5, 6 sig figs. These zeros were sandwiched. This one was after a decimal, after non-zero digits. So this part of the scientific notation number also has 6 sig figs. Now I'm going to add one last hint. Sometimes, after doing calculations, let's say your calculator tells you, let's say it says like 56 times 10 to the second, and you want to convert that into proper scientific notation. So 56, the decimal is here, but proper scientific notation would be 5.6 times 10 to the something. And we want to figure out what is that new something. It's not going to be 2 anymore, it's going to be something else. Now, to go from 56 to 5.6, we have to move the decimal point 1 spot. So this is either going to go down to a 1 or up to a 3, but this is my hint on how to figure out what you do. So the way I think of it is to go from 56 to 5.6, I'm making that value smaller. So I'm going to make my exponent larger as a result. So the 2 becomes a 3. So 56 times 10 squared becomes 5.6 times 10 to the third. I'll do another example. Let's say after doing something on your calculator decides that the final answer is 0.43 times 10 to the negative 2, but you want to put your answer in proper scientific notation, which means you want the decimal point to be here between the 4 and the 3. So to move it from its calculator given location of, between the zeros over to between the 4 and the 3, going from 0.43 over to 4.3, you're making that number larger. So the exponent, you're going to want to make smaller. If you make one larger, you make the other smaller. If you make the regular number smaller, then you make the exponent larger. So we started with 10 to the negative 2. We make the exponent smaller by that much. And by smaller, I mean more negative. So 0.043 times 10 to the negative 2 becomes 4.3 times 10 to the negative 4. We moved it over 2 places, so we make it more negative by 2. So it goes from negative 2 to negative 4. I think I should do one more example. So how about 0.00357 times 10 to the negative 1 is what your calculator told you. you want to put it in proper scientific notation, which means you want the decimal here. We're going to have to move it this way 3 times, going from 0.00357 to 3.57. We've made the number larger by doing that. So the exponent, we want to make smaller, and I mean more negative. So it's going to become 3.57, -1, more negative in terms of more negative 3 times, it becomes -4 because we moved it 3 places, 1, 2, 3. So it's going to become 3.57 times 10 to the -4.